Hello, everyone. Welcome back to the Dev Den. Make sure you grab one of these headsets. There's a bunch of them at the back if you want to follow along. And I know Munib is going up on the other stage at 2:30, but fear not, you should stick with us because he'll go up again at 4 o'clock for a big interactive session. So make sure you stick around for the next section. All right, up next we have Ludo and Micaiah, who are going to talk us through deploying updates on chain and other cool stuff with Smart Contract Runbooks. So welcome Ludo and Micaiah from Txtx.
Hey, good afternoon, Nashville. So I have my poker face, but we are incredibly excited to be here and demonstrate what we've been building at Txtx. Sorry. Okay, all good. Okay, so before talking about the product, let's start with the team. So I'm Ludo. I joined the Bitcoin ecosystem 5 years ago for building Txtx V2, the first Bitcoin L2, while my co-founder Micaiah was working on Ganache at Consensus. You can boo if you want. And so, yeah, so we are coming from two different ecosystems, but we are sharing our fascination for blockchains. Yeah, we believe that blockchains are the right foundations for building the future of money and finance, and we want to make sure that you guys, you builders, have the best foundation for building this future. Like, you deserve to have the best infrastructure and tooling for that. And so today we are here to introduce a new primitive for those builders. Okay, so let's start with a typical Web3 developer journey. So when you start building a protocol on Web3, you basically go through 4 phases. Step 1, so you pick a blockchain and you develop a protocol. So you, depending on the problem you're trying to fix, you will be optimizing for speed or decentralization or privacy. And then you attack, you write the code. So yeah, essentially writing Clarity, Bitcoin script, Solidity, you name it. Then we have the debug phase. So by debugging, I mean writing unit tests, integration tests, fuzz testing, running security scanner, whatever works for catching those bugs. And then we have the deployment and the operation phase, where so yeah, basically developers are moving from code living on their machine to contracts living on chain. And so yeah, so on the operation side, for instance, if you are running a DeFi protocol, you may have to tweak some smart contract parameters, run some DAO decisions, or even like publish contract upgrade. And so if you talk with Web3 developers, yeah, deployment and operations are a suicidal hotspot for startup, like crypto startup, in the sense that every year between 500 million and $1 billion are being hacked and lost in compromised private key. And what is the reason one for compromised private key? Poor operation standards. So yeah, if you look at, so on Web 2, we were able to reach a level of maturity that we haven't been able to reach on Web 3, thanks to tools like Ansible, Terraform, Kubernetes. Yeah, on the Web 3 side, we are still stuck with long bash or JavaScript files, encoding, signing transactions. We are copy-pasting private keys in there. And yeah, we end up losing a lot of money with the process. So with Txtx, we are introducing the concept of smart contract runbooks. A smart contract runbook is a workflow or a recipe designed to sequence block interactions on blockchains. And so, yeah, the goal is to help developers create something concise and clear to read. And yeah, but most importantly, pay attention to security. If we zoom in on the anatomy of a runbook, so we have key 4 properties. A runbook needs to be declarative, so we have this clear language where developers are describing the interactions they want to do on-chain. We are trying again to be as concise as possible, and so by being concise and clean, we are increasing maintainability. We also want to have composability, meaning a runbook can call into another runbook. We want those runbooks to be explainable, meaning documentation is a first-class citizen. And finally, extensible in the sense that, we want to be able to support any chain. So, all right, we have a runbook. What's next? So concretely, Txtx is a standalone command line tool that anyone can install on their machine. And so you can run the scripts that you're writing in a terminal like you would do with any other scripting language. But you can also run it using a supervisor. So we have this web UI allowing you to control step-by-step the execution of the actions you're doing on-chain. And since everything is being done through a web browser, we can leverage web wallets and make those runbook execution collaborative and multi-party. So yeah, the goal is really to bring confidence to developers. And yeah, speaking of confidence, Micaiah, how would you feel about a live coding demo?
Sounds good. Okay, so like Ludo said, we're making this way to make a runbook. So we're going to have a TX file. It's a declarative language. So we're going to get started by declaring some shit. So we're going to touch a file called abc.tx. Touch, apparently. Touch abc.tx. So we've got a file, abc.tx, and we are going to build a runbook. So we will declare first an input, and we're going to call it A, and we're going to give it a value equals 1. And then we can do another input, call it B. We're going to give it a value of 2, but instead of calling it value, we're going to say default here. You'll see in a second, but this is going to allow the user who's executing the runbook to actually change live what's going to happen. And then we'll have an output C, and the value is input.a plus input.b. Save the file. We have built our first runbook. If I spelled everything correctly, we can say txtx run abc.tx. So I'm going to pass the -u command here. What this is going to do is it's going to run in unsupervised mode. So it's just going to execute. There's no steps to verify. So for some debugging steps or like deploying stuff on a DevNet, you may just want to run through it, execute it with a fake mnemonic. You don't need to supervise things, so you can do that. But then we can get rid of that. We can run it in the without -u. So now this is in a supervised mode. So we've got this on our local host. We can go through the steps of the runbook here. Because we set B as a default instead of a value, we can change this, and we can validate all of the values. So you're given a step-by-step of everything you're deploying on chain. You can verify it all, validate, and we have made a very complicated calculator. We now know that 5 + 1 = 6, which is great, but why? So these building blocks we can take to make stuff that's much cooler. So we're going to do something a little more complex here. Here I have a project that has a Clarity contract. You've probably seen this before. It's a counter contract. It's just stores a count that we can increment and decrement and add to. And so we're going to build a runbook to interact with this. So we'll do Txtx new. We can decide like what type of runbook this is. We'll say this is maintenance. We're going to call it counter. We can give it a description. This runbook calls the add and get count functions of the counter contract. And we've built a runbook, counter.tx. We can do txtx ls to see all of the runbooks that we have managed by our manifest here. And so the manifest has got this runbook and some environment variables that are set by default that you can set whatever environment variables you want. And we'll get rid of this default code, and we're going to start interacting with this. So if we look at the contract, we've got the get count function. And if we look at Txtx's docs, let's see what we can do to call this read-only function. So we've got these actions, call read-only function. And so we've got an example here of what we can do. We're going to say action, give it a name, and stack send contract call. So we have this Stacks plugin. So let's do that. We're going to say action, count. That's going to be what the result of the data is. So we're going to give it a name count. We're going to say stacks, call, read-only function. We look at the docs. We're going to need to give it a contract ID, function name, function arguments. Let's do all of that. So the contract ID is, we can look at our deployment plan, get the address, dot counter. So that's where the contract will live. Oh my gosh, I should start my DevNet before we get too far into this. So this actually lives somewhere. DevNet started. All right, and then we need the actual function we're calling. Function name is get count. Function args equals, there are none for this contract call. We don't need any arguments. And then there's this RPC API URL that we need. So many of the actions are going to need this. And so we have a way to actually just set these defaults so we don't have to specify them again and again. So we'll say runtime, stacks, defaults. We're going to say RPC API URL is our DevNet, so HTTP localhost 3999. Oh, I'll need a colon there. And then another default we'll need is the network ID. This is on DevNet. I think that's everything we need. Let's take a look. Oh yeah, we need a sender for this read-only function. So because this is a read-only contract call, we're not actually sending anything on chain. This is just extracting some data on chain. We still need a sender of this, so we'll put that here. And then now we need a way to output this data, so I'll make an output, the count. And its value is action.count. So with this, you can see that we can reference previous actions that have been run. If I save this, I'm going to run it in txtx run counter -u. So unsupervised, just run through, see if I got it all right. OK, we've got the count is 0. We've just deployed this contract, but there's no value set. So we want to actually send a contract call on chain. We want to sign it so that we can update this value and actually see some information. So I'm going to do the action add. So we're going to add to this number stacks send contract call. So we've got the stacks plugin here. We're using the send contract call function. It's going to be really similar to this, that we need the contract ID. But then we need the actual what value we're going to be adding here. We don't want to hard code this. We want the executor to actually be able to control this. So we'll say the input number to add default equals 2. So now whenever an operator is actually executing this, they'll be able to set whatever value they want to use to call this function. So we'll say stacks cv uint. So we need to encode this value as a clarity value, input.number to add. And then now the one more thing that we need is the signer. So this is not a read-only function call. We're actually sending a transaction on chain. We're going to be spending some DevNet coins, and so we need someone to sign it. We're going to go the unsafe route of showing you all my mnemonic phrase, I'm going to say wallet operator. So we're going to create this wallet construct, and we have a few different types of wallets. This word is impossible to spell, mnemonic. Let me know if I got that wrong. And copy my mnemonic. Please put that somewhere. Feel free to my funds. So we've got a wallet called operator, and so we can just say the signer for this transaction is going to be wallet.operator. And I'm actually gonna copy this call so we can see the count before. We're gonna make this contract call on chain, and we're gonna do the contract the count after. So I'll call this count after. Output the count after, and that's the value we'll output. All right, we'll see if I got everything right. Just to go over, we've declared this wallet, a mnemonic wallet that's going to sign our transaction. We've got an input that can be edited live while executing it. We're going to call a read-only function to get the data before. We're going to send a transaction on chain that's going to be signed by that wallet to update the value, then we're going to get it again. So Txtx run counter -u. So we see the pending transactions broadcasted on the chain, waiting for the block to be mined, and you can set the number of confirmations you want to wait for. If you need to wait a certain number, you can set that in the send contract call. Oh my gosh, is my DevNet not running? Or did I type something wrong? Failed to broadcast it.
Send contract call, get count.
Oh yeah, wrong function. Thank you, Ludo. Let's try that again. So yeah, you get live errors of things that you do wrong when you're presenting live on stage in front of people. It's really helpful for that. We'll wait for this one to be mined. In the meantime, I'm going to make a little change here. So we are using a mnemonic wallet, not ideal. So we can use another one. We can say wallet operator. This time we're going to do Txtx connect. I see I've done another thing wrong. So
Depends on.
yeah, we send all these transactions. We can create the order of operations that you want stuff to run, which is really powerful when you've got multiple transactions that need to be sent, or you have to deploy a contract then interact with it. So we're gonna put some dependencies here. So we say that this second call depends on action.add.txid. So this isn't going to be run until this action is completed, and this one equals action dot count. Cool. And I'll get back to this other way of signing. So now we're going to use the Txtx Connect. This is using Hero's Txtx.js Connect library in the browser. So we can't run in an unsupervised mode anymore because we need some actual user interaction to sign this transaction. So all we had to do was change that two lines, provide the expected address so we can verify, like we can ensure that you're not connecting with the wrong wallet when you're deploying things, and then setting that this is going to use the Txtx Connect wallet. So we can run this now, not in unsupervised mode, but in supervised mode. There we go. So now you'll see there's more information on our runbook checklist than the ABC. We've got these environment variables, so you can set up your environment to do this on DevNet, and then you can just change this to do it on mainnet or do it on testnet, so you can use the same runbook, same deployment protocol to test everywhere. We can connect our wallet. So Txtx is generating these steps of you're expecting to sign on with this wallet, so it's asserting that you do that. We have to sign a message to provide our public key, and so now it's verified that the address you expected to be connecting is the one. It's polling the chain to see that you have appropriate funds to run this runbook. We can start it. We've got the number to add. This time let's add 10. Validate. So now I'm given this prompt. It tells me my nonce. It tells me the transaction fee. It allows me to sign with my wallet in the browser, validate, broadcasting the transaction, and it'll tell me when it's done. So now with just 2 lines, we've gone from mnemonic deployments of all of your contracts to actually using a browser wallet. Runbook complete. So now we see that the count before was 2, the count after is 12. But wait, there's more. So what if you want to use a multisig? I'm going to need some help from my friend Bob on this one. I'll be Alice, obviously. Just a few lines. So now I'm saying there's a wallet called Alice, and we expect this to be addressed. There's a wallet called Bob. We expect this to be addressed. And we have a wallet still called Operator. This time it's going to use Txtx multisig. And the signing parties here are signers equals wallet.alice, wallet.bob. So now we've converted this runbook to now be a multisig of these two parties. I can do the same thing. Txtx run counter. So now our runbook checklist looks a little different. We have multiple addresses that we have to provide. But if I'm doing a multisig, we need some way to coordinate these parties. This all is running locally. How do I get Bob's signature? So I can go here. Up on the top, we have this relayer mode. Sign in. Is my internet working? I have an internet connection. Okay. I don't know why this isn't working, but I can do this locally pretty quickly. Do we have time? 8 minutes? Okay. You're seeing some real live coding now. Cool. We'll run this on my local host instead. You can't access my local host, so I will be Alice and Bob. So in the real world, when you run this, you're giving it an HTTPS link, so I have a place for Bob to sign on. He can provide all of his signatures without we've coordinated this multisig without any private keys being stored anywhere. So he's able to sign the transaction from his machine. I do all of the coordination with the chain. So this is what it would look like for both parties. So if Bob signs on with this link, if someone else gets a hold of the link, they can't access it unless they have this one-time password that I have as the host of this experience. Actually, this is Bob. So 517-518. And so both parties can now open this assistant. Bob has got to provide his public key. He signs the message. Alice can do the same. So now we have these two public keys. Txtx is able to take those, generate the multisig wallet. We have this new address that is our multisig address. We have the balance. We can start. We're going to add 20 this time. Validate that transaction. We can see the account nonce, the transaction fee. Now we have this other assistant. So Txtx is going to have us sign in the correct order. So Alice needs to sign. Then Bob needs to sign. We send that transaction on chain. So now we've got, with a few lines of code, we've created a multisig address. We've been able to coordinate that whole interaction. Yes, that's my demo. Ludo's got a few other words here.
Cool. Yeah, thank you, Micaiah. Good job. So yeah, if we zoom out a bit, so we have this Txtx language and this tech, and so it's been designed to describe very simply blockchain interactions. And yeah, writing the simple thing that we did using this language would have been taking days in JavaScript, or like doing that from scratch would have been pretty hardcore and requiring a lot of knowledges and time. And yeah, so we have this nice language. We've been talking with a lot of developers, and we've been able to identify a bunch of different problems we can fix with that language. So right now we are focusing on deployment and operations. We are also exploring L2 synchronizations on other chains. But yeah, so we will be exploring many different aspects that sound interesting. So we are pleased to announce that the beta is available today. So if you are building on Stacks, you can start using the language, the tech. We have some good documentation. It's up to date. And yeah, so we think that this tech can be used for multiple chain, for fixing multiple problems. We think that, so we want to be chain neutral, but we started on the Stacks blockchain. The Stacks Foundation wrote the first check. And so yeah, for that, a big thank you to you guys. And yeah, so if you are building on Stacks, please come talk to us. Thanks.
Thank you.